For every question, we have to get the answer also in our brain, right? Our team leader or our seniors, first on day one, they are just going to elaborate, or they'll give a brief discussion, elaboration or a brief discussion on a project on the first day. On the day one, they'll have a meeting, one meeting. In the meeting, they'll elaborate, hi team, and we have got a project from one of the client. They'll not disclose the client name. They'll not disclose the client name. They'll not disclose what is the budget and what is the things. They'll not disclose. Just they'll say that with one of our team, one of our client has given us a project, and we have to work on this, and these are the things. And like this, they're going to give a brief intro, some intro about the project, a brief idea. Now, when they are giving that brief idea, we have to keep one notes with us. We have to keep a notes, and we have to write the running. Sir, wait, sir, I'm writing something. You wait, sir. We can't say like this. In the corporate company, we should not say like that. Right? If it is an online meeting, we have to record from our end. We have to start the recording, and we have to record everything. Right? If it is offline meeting, we have to keep a book, and we have to write the running. Whatever the running we can write in the running notes in a fast way. He will explain in a fast way. We have to also write in a fast way only. And once we have written that one, everything was completed. After this, now the meeting will be for half an hour or 40 minutes, something. Once the meeting was completed, now from that, we will, whatever we have written, from that we'll start in the Google checking one by one. And from that, we'll get some new questions. By checking, we'll get some new questions. For that new questions, again, we have to check the new answers. Like this, first we have to do the basic research. First, we have to do the basic research about that one. In the real life, that is the first one. Directly, we are not going to open the Jupyter notebook. Directly, we are not going to import the data. In the real life, first 1 week to 15 days, minimum to 15 days. First 15 days of the project will not even open the Jupyter notebook. First 15 days will not even open the Jupyter notebook. Just will understand the data and the project very clearly. For understanding the project, they'll give us 1 week of time. We are not going to understand in just 5 minutes or 10 minutes. We'll get multiple doubts. Okay, how they are going to use this one, where they are going to use this one, what is the use of this one, why they are funding us. We'll get multiple questions in our brain. And whatever the questions we are getting, every question we have to check the answer, and we have to do the basic research and understand the project, everything very clearly. And you'll get one project description also to your mail. One Word document or PDF document, something you'll receive in the mail about the project description. That one also you have to understand from starting to ending very clearly. And whatever the doubts you are going to get, you have to write in the notes, and there will be one meeting again in the evening hours. And in the evening, again, they will ask you what you have understood about the project. And there you have to explain your views. Others will explain their views. Sir, I have understood in this way, but whether I'm right or wrong, I don't know, but I have understood in this way. Just correct me if I'm wrong. Like this, we are going to discuss. And once on the discussion, others will ask few doubts. We'll ask some few doubts. Finally, we'll get some clarity. Next day, again in the morning, they'll assign the work. Evening, they'll see what is the work you have done. Morning, they'll assign. Evening, they'll check whether how much work you have done. Every day, this is common routine. Every day, 2 meetings compulsory. Morning, 1 meeting. Evening, 1 meeting. Morning meeting, they are going to assign the work. In the evening meeting, they will check the report. Right? So, in this way, first step is business problem understanding. That is the first step. Once this is completed, next we have to collect the data from database, company's database, not from the outside. Collecting the data from outside, from servers or web scraping or all these things comes under data engineer. We are the data engineer. What the data engineer will do is he is going to collect entire data from various sources. He is going to collect the data from various sources, and he will keep that one in the company's database. Whatever the information he has collected, he will store in the company's database. Company's database or company's cloud. If the company is a huge company like a MNC company, they are having the money to maintain the cloud, means they'll maintain the cloud. If they're not having the money to maintain the cloud, means they'll have the database. Startup companies will have the database. MNC companies will have the cloud, right? Now, in the company, first the data engineer will collect the data and he'll store in the database. From the database, we have to collect the data from the database. We have to collect the data from the database and we have to understand the data understand. Once we collected the data, each and every column will be there, right? Each and every column heading will be there, right? Everything we have to understand very clearly one by one. If you don't understand, you have to do the research in the Google or in the ChatGPT, whatever it is, and still you are not able to understand, you have to ask the seniors in the meetings. Okay, first the basic research you have to do from your end. Directly you can't ask as a student. We can't behave as a student in the companies. We are not the students in the companies. They are not the teachers in the companies. Seniors are not teachers. We are not the students. They are also working. We are also working. They are seniors. That's it. They are just colleagues. They are also working. We are also working. Everyone are working professional only. Everyone are same. Just they have joined somewhat early, so they are called as seniors. We are joined lately, so we are called as juniors. That is the only difference. Okay. So just we have to ask what are the doubts, final doubts we are having. We can't disturb their work. Continuously asking for multiple questions. We should not disturb them. Right? For them also the work will be assigned, right? They are not for you to mentor and they are not created for mentorship. Na? Oh, our juniors will ask some questions, so we have to clarify them. They have not given the work for that. For them, separate work is there. We should not disturb their work. Right? Now, once second step is completed, third step. The next third step is called as data preparation. Data preparation. Data preparation. It is also called as data pre-processing. Data pre-processing. Where in this we are going to have EDA, data cleaning, data wrangling, and future selection, which are unimportant variables we have to draw. These four things should be in this. Okay. If required, we have to create the futures. If in the few cases, we have to create a new futures, which is also called as future engineering. Basically, data cleaning and data wrangling is a combination of future engineering. Future engineering means as per the required, you have to create the futures or we have to drop the futures. One should be very good at the future engineering. Very, very, very good. 90% of, sorry, not 90%, more than 50% of our time we'll spend in the data pre-processing stage. Than modeling, data pre-processing is more important. Than machine learning and artificial intelligence application of algorithms, this is more important. If the data is proper, machine will give the proper answers. If the data itself not proper, if you give extraordinary machine also, it can't do anything. Right? First, data should be very clean and very perfect. Try to get to the perfect data. 100% it can't be perfect, but we'll try to maximum. Right? That is the third step. Fourth step, coming to the fourth step, modeling. We are going to do the modeling. This is the fourth step. And the fifth step, finally, the fifth step is evaluation. You are going to evaluate your model. You are going to evaluate your model. How we are going to evaluate the model? For evaluating, first we have to do the prediction. First step, we have to do the prediction. After prediction, we have to do the evaluation in terms of check our error, whatever the error or accuracy. Error or accuracy, any one of your choice. If error is low means accuracy is high. Accuracy is low means error is high. Both are opposite to each other. If you calculate one means automatically second one is done. Means to be more simplified, either you can go with RMSE in regression or R square, any one of your choice. Which one you have to select? That will be decided on the business problem. In the business problem, they'll give very clearly on which parameter we have to focus. If they have not given, we are going to ask the seniors in the meeting, what is the major requirement? Means what is the exact, is there any target of accuracy is there, or we have to do the maximum best? If they tell that the accuracy minimum 80% accuracy is required, means 80% means the meaning is R square. This much of error means the meaning is RMSE. Right? So just we are going to conclude that one in the business problem understanding only, on which metric we are going to work. And along with that, we have to decide whether this model is a good model or not. Whether it is a good model or not also comes under evaluation only. Right? With if it is not a good model, we'll try to come back to the model and we'll do some modifications in the model. We'll do some modifications within the model and we'll try with respect to best. Next, sixth one. The sixth one. Everything step I'll show you in the projects. Don't worry. Everything we'll cover. Initially, first day class na. So I mean, within the project, this is the first one na. So obviously, light confusion will be there for you. So by understanding one or two projects, you'll get full clarity one by one. Okay. Now the sixth one is called as presentation. Now, whatever till now you have done, everything you have to present. To whom? To your seniors, whoever has assigned the project, to those people, we have to present. These are the steps I have done, and these are the things I have done, and I have got this one, like this, we have to present. Once everything is okay, the project is okay, whatever you have done is nice, everything is nice, miss, then finally, the last step is you have to save the model. With this, the data scientist work will be completed. With this, the data scientist work will be completed. Now, after saving the model, next deployment team will come into picture. They will deploy the model. That is, software engineers will deploy the model. Cloud engineers or software engineers, according to that, they are going to deploy. Even that one also I'll show you. What happens next one also I will show you. The next one is called as deployment phase. This completely, whatever we have done from here to here, this is called as development phase. This is called as development phase. Project development phase. This is called as project development phase. Means you are developing your project. Okay. Means you are trying to get the best. Deployment. Deployment means whenever you are going to do the deployment, that deployment means it comes under deployment phase. And once the deployment is completed, next phase will be with respect to operation phase. The ninth one is operation phase. This will be done by the DevOps team. Okay, operations will be done by the DevOps. So those people, they are going to work on the operations. Operations means first we'll deploy our model. Once deployed, and it is going to run in the real life. And if any new errors are coming in the real life, for example, I have shared my things to the company and they are working. They have got some errors in their software. They have got some errors. To whom they are going to report? To the company people only. Whoever has given that model, for them only they are going to report. For example, in the Naresh IT, we have created one website for app login. For online students, they have to use one ID, password, and they have to log in. And from that, they have to attend this class. For example, user ID and password is not working. It is showing invalid entry or invalid password, or though you are clicking on the login also, it is not redirecting to the next page. It is struck off. What you are going to do? You are going to contact the admin. What admin will do? Admin will contact the team who has developed that one. If there is any problem, to whom they have to contact, those people they will contact. They are called as in Naresh IT. In Naresh IT, they are called as maintenance department. Their work is to maintain everything. Okay. Now, this maintenance team, now you are going to share that information to the maintenance, and the maintenance team, if they know something miss, they are going to rectify that error. If they don't know, then what they will do? They'll check with the person who has created this software engineer. The person who has created. Got the point? Is that clear? So first in the website, one person is getting clicking on the login. Okay. And login button is not working. Whatever they are entering, it is not redirecting the new page. It is not working. Immediately the student will call to the admin. Admin will call to the maintenance team, and maintenance team is going to rectify that one. But maintenance team is also don't know that one means to the software development team. So in the same way, in the real life also the same thing will happen, right? So we are in a particular project, multiple teams are going to involve. Not only the data scientist will complete the entire project, multiple teams will be involved. Out of which the first team, first team is business analyst. He is the first person. For a data science project, he is the first person. He will understand the business problem exactly. And he will get some new ideas how to increase the business. First idea he will get. Okay. And the business analyst, whatever the business analyst, he will coordinate with the project manager, and those both people will discuss to each other, and they will create a project. And after creating the project, after creating the project, once the project is approved and everything, means to be more simplified, let me explain in a real life what the things will happen exactly. Client, first thing is client. He will have the idea and money. These are the two things what he will have. One is idea he will have, one is money he will have. These are the two things he will have. But what is the missing is subject. No subject. The person is not having subject. Subject means in terms of how to create the apps or how to create with respect to cloud, how to integrate. This subject is not there. Subject will not be there. Only idea and money will be there. Right? For these people, we have to do all the necessary things. Okay. This client, whatever the business person is there, business person has got the idea and money. Now he'll come to a software company. First, he'll approach a software company. In a software company, first he will tell his idea. Hey, this is my idea and I want to design like this, and this is my requirement. He will tell like this. Now the software company team is going to say that, okay, sir, please give us some time. We'll come with a solution, and we'll tell how you can develop this entire business. That now, once this is completed, now the manager, or the manager and the business analyst, these both will discuss to each other. One person has came, he's having full of money with him, and he's also having this idea, and he wants to develop the business, it seems. Now, how to develop? How we can develop this one? And his requirement is like this, but he's having full of money. What we can do? Okay. They will discuss each other, and they will say that, sir, we'll do like this. We'll present to client, we'll say to the client like this. And if he's okay, miss, we'll create the project. Okay. Now, once they discussed each other, discuss means not for 5 minutes. They'll not go side and they'll not discuss. The discussion will be for 1 week. They'll understand the exact scenario outside the market, what is there and how it is happening, everything. So they'll take time. And now they'll call the client again back. And they'll present whatever the things they understand. They'll present to the client. Sir, this is the way we want to approach this problem. This project we want to approach in this way. And it will satisfy your requirement. Whatever your requirement you ask, it is going to satisfy. It is going to satisfy. Okay. Now, what is the budget? First, the client will ask, what is the budget? And these people will give the budget. Now, after giving the budget, quotation, everything, now again, client will take certain time. And after taking the certain time, he will give the approval. If he is interested, he will give the approval. If he is not interested, he will not give the approval. He will say that this budget is very high, so I can't bear. So simply leave this. Okay. For example, budget is okay. Everything is okay. Now we'll get the project. Now they'll keep a meeting, and in the meeting, they'll say that we got a new project. Now, new project we'll get. Till that, it is in the discussion phase. Whether we may get the project, we may not get the project. Right? Now, project is confirmed. Now, once the project is confirmed. Whatever the project is there, now once the project is confirmed, now first step, once the project get confirmed, now what is the first step is the data engineer, he is going to collect the data. For that entire project, he will collect the data from various sources. He will collect the data. Okay. And data analyst will start doing some kind of analysis from his end. And data scientist, he will do some kind of predictive analytics. And for that, next, the software developer team, they are going to deploy the model. Like this, multiple people will involve in this. For all these people, the salaries will be there. Huh? These salaries all will be included in the budget on, including the company's profit also. Including the company's profit and the salaries. And for that, whatever the infrastructure was provided, current bill, whatever it is, everything will be included in the project. Right? So, and they're going to charge from the client only. This will happen in the company generally. Okay. So if this client is satisfied, for example, the client expected the project should be completed within 10 crores. His budget is 10 crores. Assume example. I'm saying 10 crores example. Okay. Generally, the project will be of 20 crores, 40 crores, 90 crores, 100 crores, like this. Right? Now, assume that budget is 10 crores. Assume. Now, even we are having 1 crore project also. 1 crore projects are there, for 50 lakhs projects are also there. Right? Now 10 crore project is there. Now, whatever this 10 crore project, within this 10 crore, he expected this one, but we have completed the entire project in 9 crores. We can even take this 1 crore from the client also. And we can credit this one to the company's profit also. But we will say that to the client that, sir, we have given you the quotation of 10 crores initially, but we have completed in 9 crores only. Now the client will be very happy. Because you are refunding 1 crore now, he will be very happy. With that biscuit, we'll get one more project from him. Right? Actually, it is a biscuit in our words. Okay. So by giving this amount refund back, they'll feel that we are having so much of ethics. They'll feel in that way. Second time onwards, they'll give with respect to multiple projects. Second project onwards, we'll have for every project 2 crores additional amount. One time biscuit, next time onwards, enjoy. He will have the trust now. Remaining things will be continued. That is the way where the IT companies will operate. Example. Okay. In this entire story, you have to not, this is important. This is important. Okay. In this entire story, forget about this one, having the money for this, everything forget. Just fix this one. So in a project, multiple team members are going to work. As a data scientist, our work is different. As a data analyst, their work is different. As a data engineer, their work is different. Each person will do a different work. Generally, others outside who are first time, generally the students who are the freshers, their assumption is every project from the starting to ending, only one person will do. That is their miss idea. Okay. But with respect to here, in the real life, we are having the multiple teams. Is that clear? Now, so here, let us start with the project step by step. Now, the first one, what is the step one? Means first business problem understanding. So whatever the steps earlier we have written, all the steps, whatever I have written within that data science project, that is step 1 to step 6. That is up to business problem understanding to finally presentation is there, right? Step 1 to step 6. That is called as CRISP-DM methodology. That is called as from step 1 to step 6 is called as CRISP-DM methodology. CRISP-DM is cross-industry standard process. CRISP full form is cross-industry standard process. Means every industry should follow the same process. That is the meaning. All the industries will follow the same process. Cross, CR stands for cross, I stands for industry, S stands for standard, P stands for process. Cross-industry standard process for data mining. DM is data mining. Cross-industry standard process for data mining. For any data mining project, everyone has to follow the same steps. All the industries will follow the same steps. That is the meaning of that. Right? So in this CRISP-DM methodology, the first step, what is the first step is business problem understanding. So first here, the question is identify the relation between total advertising spend versus sales. So before to this, first the client, there is one person. Okay, client. He is spending some amount. He is spending, assume that I'm your senior and you are working in the company. Brief introduction about the project. How they will give the brief introduction about the project, I'm showing. So the client is going to spend some amount on TV for advertising and on radio for advertising, and on newspaper for advertising. Okay, he is going to spend some certain amount on TV, radio, and newspaper for advertising purpose. And this particular client is having a product with him. One product is there, and he wants to sell this particular product. Okay, by spending some amount for advertising, he has got the certain number of units has been sold earlier. Okay, based on the fund, the already has sold the certain number of units. For example, let us assume this one is a Apple iPhone 14 Pro. Assume. Okay, now they have spent a certain amount on TV, certain amount on radio, certain amount on newspaper. Now they have got the number of units has been sold. Okay, this many number of units. Let us see the data set. Let us observe the data set. So the data set, advertising data set. Okay, they have spent certain amount on TV, certain amount on radio, certain amount on newspaper, and this many number of units has been sold, 22,100 units. And again, second time they have spent certain amount on TV, radio, newspaper, and this is the amount, this is the money which has, this is the number of units has been sold. Similarly, TV, radio, newspaper, this is the number of units has been sold. Okay, now the client question, what is the client question is, identify the relation between total advertising spend versus sales. This is individual. Individually, I have spent certain amount on TV. Individually, I have spent certain amount on radio. Individually, I have spent certain amount on newspaper. Now, total advertising spend. Total advertising spend means a combination of TV, radio, and newspaper. That is the total advertising amount. So, I want the relation between total advertisement for the spend, whatever the total advertisement spend I have done for this versus sales. I want the relation. Is there any relation between them? If there is a relation, and based on that, if I spend in my next ad campaign 200,000, that is 2 lakhs. If I spend total amount of 2 lakhs, what is the expected number of sales? Means 2 columns are there, X column, Y column. And first you have to identify these 2 columns. And based on that, once you have to create the equation, beta 1 X plus beta naught. And based on that, you are going to identify for new value of 2 lakhs. Here 2 lakhs is there. What is the expected answer? That is the question. Means to be more simplified with you, X, Y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. First identify the relation between these 2. That is the question. Identify the relation. The identified relation is beta 1 X bar, where beta 1 is 1 into X plus 5. Where beta 1 is 1, beta naught is 5. You have identified the relation. Once you identify the relation, for 6, what is the expected answer? For 2.5, what is the expected answer? What will be the expected answer for 6? 11. 11 is the expected answer. For 2.5, what is the expected answer? 7.5 is the expected answer. With what accuracy? What is the accuracy? 100% accuracy. In this case, it is 100% accuracy because the error is going to be 0. The entire error is going to be 0. So automatically it is 100% accuracy. Is that clear? So the same way, we have to identify the relation between total advertising spend versus sales. Once we identify the relation for the unknown data, that is 2 lakhs, we have to predict what would be the expected value. That is the project. Is the project description is clear? Understood the project? So first I'm going to import the NumPy, Pandas, Matplotlib, and Seaborn. Now, first collect the data and load the data. This data was collected from my data engineering team, and I'm going to load the data. Okay. After loading the data, understand each and every variable very clearly. So TV, radio, newspaper. What is meant by TV? TV means how much amount you have spent on the TV for your advertising purpose. Amount spent. Whatever the values are there, this is the amount spent. Radio, amount spent. This is the newspaper, amount spent. Sales is nothing but number of units. What is the total number of units? Right? Now, just I'm going to do the info. Info here, it is 200 records. Total 200 records are there. So the data set consists of 200 records with 4 columns. The shape is 200, 4. 200 records of 4 columns. The column names are TV, radio, newspaper, sales, and data type is int. Everything are int. Now we have to understand whether these are continuous variables or discrete variables or categorical variables. First, what is this? Amount. Amount means money. Money means continuous variable. Irrespective of whatever inside that dot is not there, decimal values are not there, we are not going to focus in that way. Based on the column name, we are going to decide based on the column name. And no, sir, I'm not getting a column name. Instead of that, is there any other way? Miss, just ask df dot TV. You take the df of TV dot unique. Apply like this. Okay. If you apply the unique values, whatever the unique values you are having, so here you can see these many unique values are there. More number of unique values are there. And that too, 2,30,100 is there. So 2,30,100 and 2,30,200 is exactly with 100. What is the difference? And you may have 2,30,200 or 220. You may have 250 also. Anything is possible. So multiple numbers are possible. So multiple numbers and infinite number of options are there means then automatically it comes under continuous. So this is a continuous variable. This is also a continuous variable. This is also a continuous variable. And sales, coming to the sales. Sales is also a continuous variable. Basically, sales is also a continuous variable because it is also having the infinite options. 9,300, 9,301 also possible. 9,302 also possible. Infinite number of options are there. Infinite number of options are there means continuous. If you are having limited number of options in the output variable, you are having either 2 categories or 3 categories or 4 categories or 10 categories or only 20 categories. Within the 20 only we have to identify the answer, but we can't cross more than 20 or limited number of categories are there, then it is considered under discrete variable. If you are having infinite number of options in the output variable, then it is comes under continuous variable, right? So here it is a continuous variable. The output is a continuous variable. Since the output is a continuous variable, so we have to select this one as a regression problem. 1, we are having the output variable. 2, the output is continuous. Okay, it is a output variable is available. Output variable is available means it is called as a labeled data. And next, it comes under supervised machine learning. We have to apply the supervised machine learning. Within the supervised machine learning, continuous or regression or classification means since the output variable is continuous, we have to apply the regression. Now, step 3, data pre-processing. Now, what is the question they asked? They want the relation between total advertising spend versus sales, not with individual. Total advertising spend. First, we have to create a total advertising spend column. How to create a new column with total advertising spend? Just by adding the TV, radio, and newspaper. Just I have done the same. Total spend is the new column just by adding the TV, radio, and newspaper. These 3 columns I am taking and I am adding. In this way, I am going to create a new column. This new column was created by adding the TV, radio, and newspaper. Right? Is that clear? Yes. Need to check the scatter plot. We'll do that one. First, here we are creating a new column. The new column is total spend. Okay, total spend is nothing but these 2. And TV, radio, newspaper you required. They are asking what is the relation between sales versus TV? What is the relation between sales versus radio? What is the relation between sales versus newspaper? They are asking in this way? No. They are asking only the relation between sales and total spend. We require only these 2 columns. We don't require this one. So what I'm going to do, I'm going to drop the remaining 3 columns. Now I'm having exactly what I require. Only two columns. One is total spend column is there. One is sales column is there. X is there. Y is there. Now tell me how many input variables are there here? One input variable. Only one input variable. How many output variables are there? One. One output variable. If one input variable and one output variable is there, what is the algorithm we have to apply? Simple linear regression. If it is linear means we are assuming the data is linear. Whether it is correct assumption or a wrong assumption, we have to check. So first I'm going to start the EDA. In the EDA, first I'm going to start with the describe function. Describe function gives me the descriptive statistics. So what is the minimum value of the total spend? Okay. Total spend they have spent with respect to 11,700 to maximum 4,33,600. This is the maximum amount they are spending on the advertising. Minimum amount of 11,700. Right? Similarly, in the sales also, we can expect minimum of 1,600 to maximum of 27,000. Right? Now, where the standard deviation, whatever the standard deviation we are having, 92,985 is the standard deviation. And for the sales, 5,200 is the standard deviation. Average amount they are spending is 2,08,860 is the average amount which they are spending generally. Right? So this basic information I'm going to get. And second, I'm going to apply the pair plot. Why pair plot? If you apply the histogram separately, if you are checking with respect to scatter plot separately, instead of doing two things separately, drawing the scatter plot, drawing the histogram separately, I can get both of them in a single shot by using the pair plot. So by applying the pair plot, I'm going to get the histogram at the same time scatter plot. Now in the pair plot, I'm having two scatter plots, out of which scatter plot I have to select, whether this one or this one. Means first check your output variable. What is your output variable? Sales. Input variable is total spend. Now check here. Now for this scatter plot is having the output variable sales on the y-axis, input variable on the x-axis. Now coming to this scatter plot, sales is here, total spend is here, which is opposite. Input should be on the x-axis, output should be on the y-axis. So that is this one. So this is the scatter plot which we have to focus. This is our scatter plot. Now from this scatter plot, where I'm having the output is sales and input is total spend. Sir, I'm getting confused in the scatter plot. If you're getting confused, means simple. SNS dot scatter plot. Just separately take the scatter plot. SNS dot scatter plot. And within the scatter plot, you write the x is equal to df of total spend, comma, y is equal to df of sales. Simple. So automatically you'll get the scatter plot. So the same scatter plot, that one and this one are both are same. I require the output variable on the y-axis, x variable on the x-axis. So this is the scatter plot. From this scatter plot, I can understand the line is a straight line. I can fit a straight line. Now, what is meant by fitting a straight line? What is the meaning of fitting? What is this line? Means nothing but, let us take like this. Now I'm having original data, X and Y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 1, 5, 2, 6, 3, 7, 4, 9, 5, 10. Total 5 points are there. And if you join all these 5 points, and this line plot, whatever the line plot we are having, that is between 1 and 5, and between 2 and 6, between 3 and 7, and 4 and 8. Sorry, 1 and 6, 2 and 7, 3 and 8, 4 and 9, and 5 and 10. Whatever the points we are having, if you join the line plot, this is the original line. This is the original line. Now I'm having with respect to predicted values. For example, let us assume there is a call line. Let us take x plus 6 something. Sir, it is x plus 6, x plus 5. I also know, but assume it is x plus 6. If I take the x plus 5, you can't see the difference. So X plus 6, assume X plus 6 is there. Now X plus 6 means here 7, 8, 9, 10 and 11. Now I'm going to make a scatter plot between X comma X Y bar, Y hat, between X comma Y hat. That is 1 comma 7. This one, this one, this one, this one, this one. And if you make a line between X comma Y hat, if you make a line between X comma Y hat, this is called as predicted line. This is called as predicted line. This is called as original line, and this is called as predicted line. Original line was made between, how you have created the original line between X and Y. How you got the predicted line between X and Y hat. This is called as predicted line, a line between X and Y hat, right? That is called as Y. Now, our ultimate goal is this both should be almost close to each other. The original line and the predicted line should be close. If it is both are same, perfectly both are same means 100% accuracy. We required with the more close to the original line. Our prediction line should be more close to the original line. Now, here, if you observe this scatter plot, in this scatter plot, if I make, this is the X value and this is the Y value. This is the original Y. And this is the predicted Y. For this X value, this is the original Y and this is the predicted Y. Original Y, predicted Y, something you are having. And if you make a plot like this is the predicted line. This is called as predicted line. Now, in this case, just observe, we can draw a predicted line in a linear way, or we have to draw a predicted line in a curved way. We can draw a predicted line in a linear way. So we are assuming, predicted line can be drawn in a linear way, and we are assuming it is a assuming. We are assuming. We don't know 100%. We can't confirm 100% based on the scatter plot. Just we'll have a basic idea. Okay, whether it is a linear or not, just we'll have a basic idea. We'll assume that they are linear to each other. They are having a linear relationship. Since they are having a linear relationship, I'm trying to apply the linear regression. Right? Sir, why we have to assume, sir, and why we have to apply, sir? Don't assume, don't apply. Why we have to assume and why we have to apply? Out of all the machine learning algorithms, linear regression will be very fast. For example, assume I have applied the linear regression and I got the accuracy. I got an accuracy of 94%. Okay. And I have applied the nonlinear regression and I have got even 94%. I have applied lasso regression and one more regression concept and I have got 94%. Now, out of all of them, if accuracies are same, what is the top priority means? First top priority is accuracy. For example, here the accuracy is 96 means I'll blindly go with this regression. I will not even have a second thought also. Blindly I will go. If multiple algorithms are having the same accuracies, then this is the first choice. Second choice is time. I want with the less time. Out of all of them, which will have the less time is linear regression will have the less time. Because the equation is as simple when compared to others. Linear regression line will be very simple. So whatever the max extract we have done, that is the easiest one within all the algorithms. In future, we will discuss for remaining things now. When compared to that, that is the easiest one. Right? So if you go with if we are comparing with multiple algorithms, linear regression will have in the less time. That is the reason. First, we'll try to fit with the linear regression and we'll try to bring the answer with using the linear regression only. What are the things we can try by using the linear regression only? We'll try maximum. We'll try to fit the entire data with linear regression only because the time will be very less. That is the reason. And second reason is this is the base model for entire regression algorithms. This is the base model. For all the regression algorithms, this is the base, starting base model. So 100% on the given data, if it is a regression related data set, 100% you have to apply the linear regression. Though the data is not linear also, you have to apply linear regression. 100% you have to do. No doubt in that. 100% we have to apply the linear regression. For the regression projects, linear regression 100% we have to apply. Is that clear, guys? Now, next correlation matrix. I'm going to see the correlation. The correlation between them is 0.86, which is a very good correlation. And that too positive correlation. The sign is positive. What is the meaning of positive correlation? As x increases, y also increases. You can see in the scatter plot also, the direction is positive. The line is like this. If the scatter plot line is like this, correlation also will be in the negative. Okay. Now, next, we are going to check whether is there any missing values in my data set. No missing values. And here encoding, no encoding is required. In the data cleaning and data wrangling, cleaning the missing values is compulsory, mandatory. Treating the missing values is mandatory. Treating the outliers is not mandatory. You may treat, you may not treat. Okay. And second, encoding. This is also mandatory. These are only two of them are mandatory. Scaling, transformations, discretization, and whatever the others are there, everything are optional. This one is mandatory. These two are. Why these two are mandatory? Why? What is the reason? Because without the data, for example, missing values are there. Without the data, machine will not understand anything. It will throw the error. With encoding, without doing the encoding, if you send the text data also, machine will throw the error that I can't identify the relation, because to apply the max, text data is there, male and female you are sending like this. How it will apply the max on that? How to calculate the mean value, how to apply all these things. So it can't apply anything. So it will simply throw the error. So these are the two things are compulsory. In my case, no encoding is required. Right? Now, X is equal to DF of total spend and Y is equal to sales. I'm going to consider the X is equal to DF of total spend and Y is equal to sales. And next, from sklearn.model selection, import the train test split. From sklearn.model selection means your model is a good model or a bad model means first you have to divide your data into two parts. One is training part and second one is called as testing part. Which training part will you have to give for the model to understand? On the testing data, you have to test your model, whether it is giving a proper results or not. Is that clear? Now, here, whatever the train test split is there. Sir, no missing values, that's why no wrangling. No, not like that. Missing values are not there means only data cleaning is not there. Data wrangling means I have written clearly no encoding. Why no encoding is there means no text data. Since no categorical data. So there is no categorical data. Everything is continuous only in our data set. No categorical is there. So no encoding is required. Since no categorical data. Okay. Now, train test split. Coming to the train test split. Let us understand this train test split very clearly. One of the most important one. So here, train test split. So whatever the train test split is there, one, train and test on the same data. Whatever you are training and test on the same data. Second, train test split separately. These are the two things, right? So first one, for example, you are having a data set like this. Okay, this is the data set. For this entire data, you are using for the training purpose and you are creating one model. Entire data you have used it for training and using the entire data, you have created the model. Once you have created the model, within this part of the data, you are sending to the machine and you are asking to predict the values. Part of the data, you are checking, cross-verifying. And the model has predicted the values like this. And these are the original values. Original values are there, predicted values are there. And from that, what you are going to do? You are going to calculate the mean square error like this, RMSE, whatever is there. So this entire data you are using for training purpose and part of the data you are using for the testing purpose. Now, in this case, there is a problem. What is the problem? Is high train accuracy will be there, low out of sample accuracy will be there. The problem, to be more simplified with you, to understand in an easy way. For easy way to understand only, I'm taking this example, guys. For understanding in an easy way. Generally, normal colleges versus premium colleges. What is meant by premium colleges means like IIT, NIT, BITS, these things comes under premium, right? Now, why these people are called as premium? The reason behind that. What is the reason behind that? In a normal college versus a premium college, let us understand the difference. Everyone will assume what is the common difference everyone will assume is in the premium colleges, labs will be top, professors will be very high. These are the two things. Generally, the students will think in this way, but this might be one of the reason, but this is not the actual reason. This is not the 100% reason. This is not the 100% reason. The reason behind this, what is the difference between a normal college versus a premium college? The difference is here in the premium colleges, if the professor says something to the student, they'll accept that one. The student will do 100% with that. Means if they share assignment, means the student will do that assignment. Instead of saying one new story, he will simply do the assignment. He will not try to skip that one by creating some stories. If he has not done the work means he'll genuinely accepts. Okay, he will not tell any stories. And main purpose here is they'll accept the professors. What are the professors? In the class, even the professor will not teach entire things in IIT. I am the alumni of IIT and BITS. And I am 3 premium institutes I have done. That is IIT I have done, BITS I have done, and from IIM I have done. I am an alumni of from these 3. So at the same time I have done with the normal college also, right? Now coming to this, here the professor, whatever the professor is there, the professor will not even teach entire things in the class. He will teach only the part of the things, and he will ask us to learn more things from the internet or with respect to from the library. Okay, he will give an idea, but he will try to cover maximum things, but at the same time he will not cover the entire syllabus also at the same time, right? Now the students used to learn more things on own. Here the students will learn more on own. They learn more on their own. This is the first major differences. This is the first. Students learning on their own. Okay. In other colleges, if the student gets a doubt, generally the student means first time they are learning something new. Obviously, the student will get the doubt. That is common. If I also read something new means automatically, if the professor also reads something new means he will also get the doubts. Getting the doubt is common for everyone. Getting the doubt is not a wrong thing. But once you get the doubt, are you going to learn on your own? Are you going to identify the solution on your own, or you are going to depend on others? That is the question. Getting the doubt is not a wrong thing. After getting the doubt, how you are going to solve that doubt? That is the important part. Here, the student will try to solve on their own maximum. On their own only. Before asking to the professor, they'll try to solve on their own. And here, in this case, the students immediately, whatever the minute doubt they'll get, immediately they'll approach the teacher. I mean, professor. That is the difference. Okay. That is the first difference. Which from IT perspective, I'm saying, from IT industry perspective, why they'll give the top priority for premium institutes? The reason I'm saying. After analyzing all of them, this is from the data analysis, not my opinion. Based on the past data and based on the analysis, this is the conclusions which I'm giving. This is not my opinion only. Okay. So why the IT industry people will give the top priority for IITs or NITs or BITS? For example, Infosys is there. Infosys coming for the campus placement. The same Infosys is coming for a normal college. The same Infosys is going for the IIT. In both the cases, from the normal college, they are hiring the BTech CSE people. In the IIT also, they are hiring the BTech CSE only. Both of them are BTech CSE only. Both of them are freshers only. In this case, freshers, in this case also freshers. But here they'll give a very high package. Here they'll give a low package. Why? What is the difference? There are any special? IIT people miss any special? Something? Why they'll give that much of a high package for these people and while they'll give a low package for these people? What is the reason? Means these people, the reason behind this. Now you'll understand the reason. Clearly you'll understand the reason. Here in this IIT, whatever the question, whatever the things was discussed in the class and in the question paper, it will have the application. In the question paper, it will have the application. Whatever the class they have discussed the topics, the application oriented questions will be there. Okay, to check how much they understand the subject, concept oriented questions will be there. But in normal colleges, whatever they have discussed in the class, as it is, same question should be there in the question paper. Otherwise, out of syllabus. Same question should be there. Whatever the sir is saying in the class, as it is, should be there. That is the requirement. And in the normal colleges, first thing, whenever we say that exam, internal exam or external exam, first thing, sir, important questions, sir. First one. Second one, after important questions, sir, textbook, sir. Which book we have to prepare? Tell the one textbook. Okay, textbook also okay. Sir, page number, sir. Okay, page number. Sir, which paragraph, sir? From here to here, can you make a tick mark, sir? Okay, that is also okay. Sir, sure, na, sir. Tomorrow this question will come na in the exam, na? 100%, right? 100%, right? Blindly we have to write from here to here only, right? Sir, first you ask question or first I have to write answer and later question? Which one is first? This will be in the normal colleges. Tell me guys, in this class, how many of them have asked you the important questions earlier? Right? We know, right? Why just whatever the important questions we are asking? Common, that is common. I'm not saying it is a wrong. That is common. The training will be like that. The society will be like that. Other friends also will be like that. Obviously, we'll also be in that only. If everyone are going in one train means why we'll go in another train, we'll also go in the same train, obviously. Right? So the same thing will continue. Here also, the same thing will continue. Others, first the professor will not encourage this one. If you ask important questions, he'll say, open the Google and check. Whatever the questions are there, the same thing. If you are asking me questions means what I am saying, the next week will be the test, Saturday will be the test. What are the questions? Did I tell anytime one question at least? Did I told any textbook? Any particular textbook name? Forget about page numbers. At least I have not even told the textbook. I ask you to prepare on your own completely. Right? Here, everything will be of spoon feeding. Now, what is this spoon feeding means? At the end, what happens? Here, sir, why all this story for us means? Now you'll understand the story, the reason of saying all this story. Now, whatever we have got trained in the class, within that only we want the test. Whatever the questions was discussed in the class, only those questions should be there. In the class, they have given the difference. One table they have written. Exam also the same question should be there. The same table we have to write, same points we have to write. So in the class, whatever they have explained the topics, in the test also, we are going to do part of that. Part of the data which was used in the class, part of the data we are using for testing. Right? What happens in this case means that students will get a very good CGPA, 8.4 also they'll get. 8.4, 8.6, 8.8. Some people will get 9 CGPA. But outside, once they come outside, they'll not have any stuff. Where 8.4, what is that person will not get the job. What is CGPA of 8.4 means? 84% in BTech. 84% of in the BTech means how much subject he has to have. But once he comes outside, he will not even have the job also. Is there any correlation? Is there any correlation between your BTech percentage versus what is the work you are doing? Because these people, are trained with the same questions as it is. They'll by heart or they'll understand whatever it is. They'll fix within that data only. They'll not come out of the data. The data is fixed for them. In this only they're trained. In this only they have test. So that is the reason their train accuracy is very high. Train accuracy means CGPA. If they check with the out of sample, means outside industry, they are worst. The thing is that this is that high train accuracy, out of sample accuracy row. This is the meaning of that. For this explanation, I have told all this entire story. Right? So train accuracy will be there. If you train the entire data, if you give the entire data to your machine, and within that, if you ask some of the data points, already has got trained now. Already the data points got trained. So within that only you're asking. So already it knows the answers also. Within that, it is going some answers. Now accuracy will be very high. Comparatively, the accuracy will be high. For unknown data, new data, it will not perform very well. Now this is a wrong type of doing in the machine learning. In the real life also it is wrong. Not only why machine is doing perfectly means it was getting trained perfectly. Right? Now, what is the right approach means? The right approach is part of the data you have to use for training. You have to split the data into two parts. First, part of the data you have to use for your training and part of the data you have to use for testing. Now, whatever the data you are using for the training, the machine has to get trained only on this data. The machine don't know whether this data is available also. The machine don't know. It will understand, oh, you have given only these 6 records and it will understand only 6 records. If you give 10 records, means it will understand 10 records. 20 means 20. Whatever the data you provided to the machine, it will understand. Whether it is a trainer, tester, it will not name like that. Just whatever the data you have given, it will understand and it will identify the relation between them. Now for the unknown data, completely for the new data, you are asking the machine. Now whether this data have you trained to the machine earlier? No, this data was not given to the machine earlier. This is a completely new data for machine. It is a new data. Now for the new data, it is predicting the new answers. And now if you compare with the original answers and the whatever the machine has predicted, this evaluation is a proper evaluation. This is a proper evaluation. The earlier evaluation is a wrong evaluation. This is a proper evaluation. And now we have to compare whether this data is doing very good or not. Now we are going to get more accurate evaluation on the out of sample. In this earlier case, low out of sample accuracy. Unknown data, we have to check every time on the unknown data. That is the reason I have told you that check in the Google interview questions on this particular topic. Did I told the interview questions list and did I told like that? If you ask me interview questions or something, what I have told, just open the Google, type interview questions on descriptive statistics for data scientist, interview questions on hypothesis testing for data scientist. Now in the Google, whatever the interview questions you are going to get, every website you can open and whatever the interview questions are there, every interview question you can see. That was not discussed in the class now. That is completely a new one. That is completely a new one for you. That is, if you are able to answer that questions also very clearly, means in the real life, in the interview, you will easily get success. Is that clear, guys? So here the entire data, whatever the entire data I'm having, in the entire data, we have to take part of the data for training and part of the data for testing. Okay. Whichever the data you are using for training, that data you should not use for testing. Testing data should be different. Training data should be different. Then how it is performing on the new data, we can understand. On the unknown data, how it is performing. And if it is performing very nice, miss, then we'll go according to that. Is that clear? This is called as train test split. We should not do the train and test on the same data. We have to do separately. Right? Most important one. For doing the model, whether it is a good model or a bad model, miss, in this way we are going to understand. So here I'm going to divide whatever the data I'm having from sklearn.model selection, import train test split. I'm going to import the train test split. This is the function. And this function, whatever the function I'm going to import, okay, just I'm going to import this line separately. I'm writing here. I'm importing this line. Okay. Once I have imported, now what I'm going to use, train test split. I'm going to write train test split is the function name. And within that, x comma y comma test size of 0.2. Whatever the test size of 0.2. Okay, test size of 0.2. What is meant by test size of 0.2 means 20% is used for testing purpose. Now total how many records? The original data consists of 200 records, out of which 20%, that is 0.2 into 200, which is equal to 40. So 40 records I'm using for testing purpose and 160 records I'm using for training purpose. I'm splitting the data into two parts. Right? Now here x, now if you take only x variable will be divided into two parts. What is the first part? Train data. What is the second part? Test part. So now if you are dividing like this, you are going to get two parts. One is train data part and second one is test data part. Now train data part, I'm going to store in a variable called as xtrain. Okay, first part will be the training part followed by testing part. So second variable I'm going to store in the variable called as xtest, x underscore test. So whatever the output I'm getting into two parts, the data in two parts, one part I'm storing in the xtrain, one part I'm going to store in the xtest. Let us see. Let us open the xtrain. Whatever the xtrain I'm having, let us open. Now here you can see total 160 records are there. Randomly it is going to choose. Random sampling. It is going to take randomly. Which data it is going to select, we also don't know. Randomly it is going to choose. Okay. Next, if you go with the next one, xtest. The second one is xtest. Now in the xtest, you are having total 40 values. This is total of 40 and this is of total of 160. If you ask a shape, dot shape, what is the shape? 40 comma 1. If you ask what is the shape of xtrain dot shape means, it is nothing but 160 comma 1. Right? So in this way, I'm splitting the entire data into two parts. One is 80% of the data I'm using for training and 20% of the data I'm using for the testing. Every time the same. Sir, what is the amount of training data we have to select? Minimum of 70 to 80 you have to use for training. Minimum of 70%. You can't take 50-50. Minimum 70%. Minimum 70% of your data you have to pass to the training purpose. Minimum 70. Maximum 80. Sir, instead of 80, if I give 90, what happens? Over data. Over data leads to the over problem. Less amount of data leads to the under problem. There are two problems are there. One is called as underfitting. And the second one is called as overfitting. I'll explain these two problems. Okay. So if you give less amount of data, it will lead to the underfitting. If you give more amount of data, it will lead to the overfitting. So that is the reason that train data should be between 70 to 80. That is the maximum. So generally I will select with 80 fix. Every time I will select 80%. Similarly, test data opposite to this. If you are selecting 70% means 30% test. If you are selecting 80% means 20% of the test. So test data should be minimum of 20% to maximum of 30%. Just opposite to each other. Here 70% you are using means 30%, 80% you are using means 20%. Is that clear? Now, coming to this, here I'm writing x is equal to this one and the test size is equal to 0.2. You can write either test size or you can write even the train size. Any one. If you write train size means you have to write 0.8. Then 80% of the data will be used for training purpose. Okay. Now the question is here, just observe this one. Now I'm executing this. What is the cell number? 21. Once again, I'm executing this cell 22. Now I'm opening the xtrain data. Now what are the data points it has selected is first record is 189th record. Index number of 189, index number of 153, 161, 96, 186. Once again, I'm executing this particular cell. Just observe this one. Again, I'm executing this cell. Okay. Again, I'm executing this cell. Now what happened? Automatically the records has changed. Earlier, what is the first record? 189th record. Now what is the record? 80th record. The records has changed. Once again, I'm executing. Okay, 24, 25. Again, I'm executing this particular cell. And again, I'm executing. This time, again, the records are changing. Each time the records are changing because it is doing the random sampling. It is going to select randomly, random sampling. So for this, the record should be fixed. For that, what I'm going to use is random state, random underscore state, random underscore state is equal to 0 or is equal to some number. Okay, you are writing some number. Whatever the number you are interested, you can write whatever the number. Just I'm writing here 0, assume. Now I'm executing this one. Now what are the index numbers? 134, 66, 26, 113, 168. These are the numbers. Now let us execute once again. Again, same numbers. Let us execute once again. Same numbers. Numbers are not going to change. If you want a fixed data, then we have to fix some random state, some number. Sir, what number we have to fix? Anything of your choice. That is not a problem. But one number you have to fix. Anything of your choice. Sir, if I change the random state number, automatically data will change or not, miss? Data will change. Sir, as the random state number changes, data changes, miss, model will change. Everything will change now. Yes, for that only cross validation is there. Okay, one by one. You will get one by one. As of now, just we have for fixing the data, we are going to write random state. We are going to assign random state with one number, some number. For every time fixing the data, we are going to assign the random state with number. Now the question is, why we are fixing? Why we are fixing? That is the question. Why we have to fix? If you want to compare, if you want to compare between the models, if you want to compare between the models, which model is best? If you want to compare between the models and identify which model is best, then we have to fix the data. We have to fix the data. Data should not change. We have to fix the data. Okay. Now, for example, sir, what is this meaning? Just understand. We want to compare between the models. Assume the models are nothing but trainers. For your easy understanding, I'm saying we are having trainer X, trainer Y, trainer Z, something 3 trainers are there. Between the 3 trainers, which trainer is the best trainer? Okay. First, you are going to listen to the X trainer, one particular class. You are going to listen. You listen the class of X trainer. You listen the class of Y trainer. You listen the class of Z trainer. From after listening all of this, you will conclude that, sir, Z trainer is very nice. Why? Means, sir, he has explained very simply. Okay. You don't know now here whether the topic is same or not. If the topic is same, then it is a right comparison. For example, topic is different. Z trainer has selected a very simple topic. X trainer has selected a difficult topic. Then how you can compare? X trainer has selected a difficult topic and he is explaining the concepts. Difficult topic to digest generally by students, it will be somewhat difficult. Difficult topic means to digest that one, to understand that one step by step very clearly, it will take some time. Whereas simple topics will be there. To understand that one very easy. For linear regression, yesterday we have done so much of maths. There will be one algorithm, KNN, will complete in 5 minutes. The algorithm only will be completed in 5 minutes. The theoretical part will be completed in 5 minutes. Dead easy algorithm in entire machine learning. Of course, worst algorithm. That is secondary. Easiest, and this is also called as lazy algorithm. The name of KNN is called as lazy. It will do very slowly. But theory part is very simple, right? Now, here, this, if, for example, the jet trainer has selected KNN, and this trainer has selected a linear regression. How you can say that this trainer is best or this trainer is best? Then it is called as a wrong comparison. Now, instead of that, ask 3 trainers to give the class on the KNN only. Listen to the 3 trainers KNN only. Everything KNN only. Now, you identify which trainer has explained that entire KNN in an easy way. From that, we are going to conclude which trainer is the best trainer. Then it is a right analysis. So in order to compare this one, the other parameters should be constant. If you want to compare one, means other parameters should be constant. The remaining all the parameters should be constant. Then only the proper comparison will be done. Without that, now, for example, as I have told you here, different trainer is explaining a different concept. Then how you can compare? For example, you want to compare my class only. I have explained the linear regression, and you want to compare this same thing in the YouTube with another trainers. So just check the linear regression only in the entire YouTube. You go with type in the YouTube linear regression. Multiple people has explained the linear regression in the YouTube. Just observe that one. Open that. Just understand one by one, step by step. And then you can compare which trainer has explained in an easy way. Whether SRK, whether that YouTube or some other, whatever the YouTube channel, XYZ, something. Then it is called as proper analysis. If you're not comparing with the same topic, then it is not called as proper analysis. So if you want to compare, similarly, if you want to compare between the machine learning algorithms, the data should be constant. We should not change the data. So in order to fix the data, we are using the random state. That is the reason of using the random state. Got the point? Instead of this explanation, I can simply say you have to use this code like this. In one shot, it will be completed. But what is the reason? Why we have to do like that? Are we monkey? No, right? To do whatever that some person is saying something, we have to do blindly. Then what is the difference between a monkey versus a human? Right? We have to understand the reasons within the everything. Right? So here, we are going to divide the data like this. Now, in this case, what happens means the data will be fixed. The data is not going to change. Now, the same data, what are the same data is there? This data I'm going to give to the machine learning algorithm 1, for machine learning algorithm 2, for algorithm 3, algorithm 4. Like this, for every algorithm, I'm going to share the same data. And out of all of them, which algorithm is best suited for my data set? That is as the final model. I'm going to decide as the final model. I will try with the linear regression. I will try with non-linear regression. I will try with others also. And finally, I will decide which is the best one for the given data. Fixed data. Data should be fixed. In order to compare between the algorithms, the data should be fixed. For fixing the data, we are going to use the random state. Now, similarly, X you have divided. Now, if you take the Y, if you open the Y, now Y also will be split randomly. But whatever the X records I have taken, similar Y records should be considered, not with a different. So what I'm going to do here, I'm going to write the Y also. Y also on the same. If I don't write Y here, if I take the Y separately, if I divide the Y separately, then I may get a different records. The sequential order will be different. Means here 134, 66. For 134, this is the X. So for same 134, same Y we have to consider, not a different Y now. This is the input, means the same output we have to consider. Same record output we have to consider. So that is the reason here we have to use the Y. I'm using in the same data Y. Now Y also will be split into 2 parts. So the 2 parts are this one. One is Y train. I'm going to store in the Y train. And the second one I'm going to store in the Y test. One is Y train and one is Y test. Now the first one will be divided into 2 parts. The second one also will be divided into 2 parts. Total I'm going to get 4 parts. These 4 parts I'm going to store in the 4 variables. Left side 4 variables are there. Multiple variable assignment. The first part will be stored in the first variable. Second part will be stored in the second variable. Third part will be stored in the third variable. Fourth part will be stored in the fourth variable. Is that clear now? Train test split code. So total 4 parts you are going to get. And those 4 parts we are going to store in the 4 different variables. Now, let us open now the xtrain. Let us open the xtrain. What are the xtrain? 134 record, 66, 26. Let us open the y train. Whether same index numbers are there, 134, 66, followed by 26, followed by 113, followed by 168. Same index numbers. If both of them are index numbers are same, is okay, you are considering the same data. Now X data is ready, Y data is ready. Now we'll have to do the modeling. Next step is modeling. That we'll do in the tomorrow's class. Okay. So one of the most important point, guys, till now, we have started the class. Actually, our class timings is 6 minutes. We have started every day around 6:10. By 6:10, we used to start and we used to end at 7:40 approximately. But we are having one more class after this at 7:30. We are having a new class. Some other trainers, not mine, other trainers, they are having the class. So from tomorrow onwards, sharp 6 o'clock, we'll start the class. And by 7:30, I will close the class. Okay. Till now, you are fixing your time as 6:10 and you are coming slowly according to that. Now, for that, I'm saying. So from tomorrow onwards, please come 10 minutes before itself. Both online and offline students. Sharp 6 o'clock, we'll start the class and we'll close by 7:30. Don't be late. And if you are late also, don't ask to repeat.